The topic for today is requirements engineering. I don't know if you've had requirements engineering in your previous education. If you have, then this is a brief refresher. If you haven't, then this is an insufficient refresher. But it's just enough to get an overview and keep it on a relatively surface level. I'm not going to go deep into any of the methods or anything like that. We have separate courses for that. And so if you haven't had a course on requirements engineering already, then I definitely recommend that you make sure you get one either in your current education program or in your future education. So the idea with requirements engineering is it's a cooperative process of analyzing whatever problem it is that you're trying to address with your software system that you're building. And the idea is to figure out what are the requirements on a product that you're trying to build. And then documenting this so that you can use it to build the software, can use it to discuss with the people who ask the requirements, and you can discuss it with the people who pay for the product and any other stakeholders that are involved as well. And there's not just one way of writing down requirements for this. There are many different ways of writing down requirements for that. You can use pictures, you can use text, you can use tables, you can use data, you can use a whole documentation, a whole standard, for example, might be one requirement. 1,000 pages full of ISO standards could be one requirement. So there's many different ways of representing requirements, and the trick is to figure out what's the best way of representing one particular requirement. And once we've developed requirements and we've documented them, we need to make sure that is this really the requirements that we have on the product? Are there any requirements missing? Are these requirements consistent with each other, or do they contradict each other in some way or other? Have we understood the system correctly? Or are we building the system right, and are we building the right system really? As I said, we have other courses for going deep into this. I think that's an old course code for requirements engineering. I think you have one which is requirements engineering and product management, which I guess is a PA1458 something or other course. But bottom line is there are courses that really go deep into how to do this properly. So this is just a broad overview to give you a sense of what is involved in requirements engineering. The reason why we have that in a course about object-oriented design is that, well, it is a good starting point, right? It's unless you know what system to build, you can't really be sure how to build it. So it's the starting step for any development effort. And in order to do proper analysis, in order to do a proper design, you need to have good requirements to start with. You've probably heard or even said yourself, the customer doesn't know what they want. Nothing could be more wrong. Of course, the customer know what they want, but they might not be able to express it in such a way that you are able to understand it. They are, after all, experts in their own domain. They know what system they're looking for. They know what help they want. You are the one who's coming in from the outside and trying to make sense of their problem domain. And therefore, you are the one who needs to be trained in understanding what they're actually telling you. And sometimes it's not easily expressed how to do a certain thing. For example, can you verbalize to yourself how to tie a shoelace as you do it? My grandmother was a good example for that. She knew how to do all sorts of food and bake and all sorts of things, but she did it with her hands. She never expressed how much salt should it be, for example, in a particular stew, how much of whatever spices, how much wheat or flour in the bread or whatever. She just felt it in her hands, this is sufficient, and then she went on. She couldn't verbalize it. So tacit knowledge is a tricky part of requirements engineering, and being able to figure out that there is knowledge here that needs to be expressed in order to go forward and in order to understand what system to build, and also then to actually find the words to, or the pictures, whatever, to express it properly. But this all assumes that you have someone to talk with. You have someone who is a domain expert that you can talk to about these issues. And that's not necessarily true. So finding whom to talk to is the starting point, really. Who knows about a particular part of the system that you're, the part that you're building? How can you find out who knows that? And once you figure out that it's this and that person, well, getting access to them is not necessarily easy. The people with the most domain expertise are probably also the persons that are most busy and most difficult to get access to, so in order to figure out what they know. So that's always a balance. And this assumes, even in the first place, that there are people that you have access to, that you can talk to, and this sort of assumes that you have a classic type of system, if you will, where you have you're ordered to build a particular system for a particular customer. If you're doing a market-driven product, you might not even have that. You might not have access to someone who is a domain expert. You'll have to figure that out yourself. You'll have to find a domain expert to build your market-driven system, because all you know is a bit vaguely that we are targeting people of a certain age in a certain country in a certain life situation, for example. And the moment you start raising your eyes a bit above the small scale systems that you build over the course of a couple of months and then you're done with it, the moment you start building systems that last for 20, 30, 40 years, or market-driven products, you run into the problem where you have more requirements than you have time to build. You actually you will end up having more requirements than you have time to deal with. So you need to find ways of handling the requirements such that you can filter away those that are already built, filter away requirements that you'll never build, filter away requirements that are duplicates of the ones that you already have, prioritize which requirements you should get more information about, and also which requirements that you can wait with. You can leave them being very vague at the moment because you're not ready to start building them yet. Planning your implementations such that you can build what is the most wanted by the customers now and in the coming X releases for the coming few years or so. So this large amounts of requirements, and we're talking about tens of thousands or hundreds of thousands of requirements that you have to sift through in order to find the requirements that are really valuable for you and the ones that you're going to work with. If you have an open issue tracker, for example, on, let's say, GitHub, you will get a lot of requirements that are disguised as bug reports. And that might be useful for you. You'll find those good requirements, but you might also you need to filter away the noise, all the requirements that aren't really requirements, all the bug reports that aren't really bug reports. So you need to have strategies for dealing with this, with that. And then once you have these requirements and you've decided that these are the requirements that you want to build on, you have to specify the requirements such that you, your customers, your developers, testers, and everyone else can understand them and can use them. And that is an issue in itself. So requirements engineering, if you pick up basically any textbook on requirements engineering, you'll find these 5 phases there. It's about elicitation, analysis and negotiation, validation, documentation, and management of requirements. What does that mean? I don't remember. Yes, no. Sometimes I've got slides that explain them in further detail, but I didn't have that today. So elicitation is the process of finding the requirements. The analogy is that you're walking around in a dark room with a flashlight and you light up, you elicit requirements as you walk. There's a requirement, that's a requirement, and so on. Of course, this is a very bad analogy because it's rarely as easy as walking around in a dark room with a flashlight. Sometimes you have to drag out the information as well. Once you have the requirements, you analyze them and you negotiate with the customers. So make sure that, is this requirement complete? Do I have all the information necessary for this requirement? Is it consistent with the other requirements I have? And if there are conflicts, I'll negotiate with the customers and see if I can do one requirement over another, how important is each requirement really? Validation is not quite the same as analysis. Analysis is on individual requirements. Validation is the requirements document as a whole, if I remember correctly. Documentation, of course, writing them down, maintaining versions of requirements collections, and remembering which versions of which requirements have you delivered to which customers, where are you in terms of implementation of each requirement, and so on and so forth. And then managing change requests to the requirements, adding new requirements to a running project, removing requirements from a project, keeping track of, again, version management of requirements and implementation thereof, and so on. Obviously, this is not a step-by-step order in which you do things. You do a little bit of all of them all the time. So as you do elicitation, you do a bit of analysis, you might do a bit of negotiation there as well. You do documentation more or less together with elicitation, and management and negotiation they also go hand in hand, and validation as well. So it's not something that you can do in a waterfall way, that you do first one, then the other. You do all of them together more or less all the time. So this was actually supposed to be a bit of discussion. So how do we find requirements and where do we find them? The first one, obvious one, is that we talk to our customers. But who is our customers? Who are our customers? Is it the persons paying for the product that we're building, or is it the people using the product? And who is going to use it? Is it just one group of users, or do we have several types of users? That's one point where we can find requirements and find stakeholders that have an interest in our product. Legal requirements might be there. If we are building, for example, a health system, then we have legal requirements on patient information and so on that we need to adhere to. Standards, which might be almost as binding as the legal requirements, that if we are developing a web page or a web application, it has to have certain accessibility standards. Competitors, if we look at other products, similar products that are out in the market, we can creatively borrow features from them and put into our own product. I mentioned the issue tracker. Looking at bug reports, we can find information there. Documentation, reading the documentation of our own product, of similar products, or just texts, novels even, written where other products are used. Observing things, we can look at how people work today, and we can find areas where we can build an application that can make their life easier, and so on and so forth. There's really no end to where we can find requirements and how we find requirements. It's more our creativity that sets the limits, and also how what type of product we're building. If it is a bespoke product, we have a customer who is paying, and we have stakeholders that are identified, end users that are identified, then maybe we'll lean towards more classic, doing interviews and so on. If it's a market-driven product, then we'll have to do other ways. We'll do brainstorming, we'll do focus groups, we'll do competitor analysis and so on. So the type of product we're building will in some way shape our approach to finding new requirements. The maturity of the product will also be an influence there. So if we have a product that's been around for a while, then our issue tracker is perhaps a good starting point to find new requirements. Talking to our salespeople, because they in turn, of course, talk to our prospective customers, so they know exactly why they can't sell our product, or they know exactly why they can sell our product, and that's also a good source for requirements. So if we have a mature product, then our sales team might be a good source for requirements as well. So there's no clear-cut way saying that for all products, this is how you do requirements engineering. It's very much finding the most suitable tool for the current system in its current state in the life cycle. A few of the techniques for finding requirements. So figuring out where to find requirements is one part. Figuring out how to get requirements is another part. This is again not a complete list, but we can do interviews. That's the most obvious way of doing requirements engineering, is that we have a couple of users and we do some form of structured or semi-structured or unstructured interview to get with them. We can use cases, connecting back to UML. So we can, together with our customers, develop use cases, or we can have use cases and we can hold discussions around them in order to enrich them with more special cases, for example. I mentioned observations, just looking at how a particular task is done and then trying to figure out how some sort of support system would help in that. Brainstorming, just sitting down a couple of, or assuming the role of domain experts by yourself, really, and then trying to spitball as many requirements as you can, or as good requirements as you can. That's, especially for market-driven products, is not uncommon. You make sure that you build a product based on an itch that you want to scratch, and therefore you are a really good product or domain expert. So when you come up with a requirement there, when you brainstorm a requirement, it's probably a good idea to, at least as a starting point, and then you can do some market analysis and see what the market value of that requirement is. But coming up with new requirements is probably not difficult if you are a domain expert. Once you have a couple of requirements, you might want to confirm them with a questionnaire, for example, where you can ask more people for their input. You probably don't want to do that much exploratory questionnaires because it's difficult to control how people answer. You'll probably want to do a couple of interviews first in order to see in which direction to go before you do a questionnaire to confirm and dig further into smaller details, but it's definitely a way of doing it. Questionnaires, then the difference being that you could actually do a very structured interview where you use a questionnaire and you ask the questions in a questionnaire face to face with your end users. But when we talk about questionnaires, we normally talk about sending out some form of survey and having them fill it in themselves. Doing a prototype, building part of the product or a mock-up of a part of a product, and then getting feedback on that. That's one way of getting requirements. and delivering something. So the moment you deliver something, the people are going to start using it, or they won't start using it, and they can explain to you why they're not using it, or they start thinking about the product, and then they'll come back with new requirements saying that, yeah, this was great, but you know what would be really good if you also do this. Document analysis I mentioned, and as I said, this is not a complete list of elicitation techniques. It's just these are the ones that are quite commonly used and quite commonly discussed, at least. One of the early things that you want to do in your requirements engineering efforts is to define the scope of the system, so that you have this boundary to say that, well, this is something that is within the scope of the system. We'll consider this for further analysis and further specification of the requirement and so on. And this is not part of the system that we're going to build, so that you can exclude that. And of course, there's this gray area in between that. Yeah, this, we're not quite sure if it's in the system or not, but let's analyze it a bit further. So it's actually triage that you're doing in the system, outside of the system, and need further analysis. But having this scope of the system, this definition of the system you're building, it's very important when the mass of requirements grows, and it's very important when you negotiate with the customers and whenever you talk to customers, so that you don't promise to do things that you in the end won't do. So having this clear knowledge that this is outside of the system is useful, so that you can focus on the things that you're actually going to build. There's a balance there, of course, especially for the parts that are on the border, the gray area. What can you afford to do within the resources that you have available and the budget that you have available? During analysis and during requirements analysis, it's we try to see the system as a black box. It's opaque, so that we try to look at what can I do with the system from the outside. So what, as a user, what can I expect to do against the system, and what should the system respond with? I would try to not look inside that box, which is was called a white box then, during requirements analysis, because I want to know what should the system do, not how should it do it. The moment we start looking into how a system should satisfy a certain request, for example, then we are doing design. Then we are making all sorts of decisions that are excluding other ways of doing things. And if we do all of this during requirements engineering, then first of all, we are in some sense, we're abdicating from the responsibility of building software system and pushing that towards the customers. If we say that to them, yeah, that's great that you tell us what the system should do, but how should we do it? Well, then you're putting them in the role of software engineers, and that's your job. But it also limits the solution space for you. So, and that's often the customers have an idea of, or express their requirements in such a way that you think it's a requirement, but it's in fact a solution. They might say, to take a really weird example, I want a red car that can drive at 300 kilometers per hour. Okay, why do you want that? Well, because I have this weekly report that I generate from my system, and within 1 hour it should be available to all my sites in Southeast Sweden. And the furthest one away is 1 hour by car, and I want to half that, so I want a car that can go really, really fast. Well, in that case, the red car that can drive 300 kilometers per hour is a solution for delivering this document, whereas an email would be another solution. or maybe even eliminating that report altogether. So when they express something, they might express it as if it was a requirement, whereas in fact it's their homegrown solution to a problem that they have. But because they're not software engineers, they don't see the abilities that the software solution could have. So now we have our requirements. We've talked to people, we've negotiated with them, and we have requirements that are consistent with each other. They don't contradict each other or anything like that. And then we want to document it. We want to specify these requirements in such a way that we can continue working with them. And the classic way of doing that is to write a requirement specification. There's an ISO standard. No, there's an IEEE standard for that, IEEE 830. That specifies that this is how a requirements document should be structured. These are the headings that should be in there. This is how you specify requirement and so on. The point with a requirement specification is that you document a common view. You document a view that is agreed upon between you and the customers that are paying for the product. You sign contracts based on these requirement specifications. So the contract is not a requirement specification, and requirement specification is not the contract, but you'll point to them. So when you sign the contract, you'll say that this contract is in relation to the requirement specification, this and that version, so and so. So this invariably ends up as some form of legal document. Even though it's not in the contract itself, it's still a legal document. This is a promised agreement between you and the customers, that you promise that the system shall be able to do the following once it's done. It's not only what it's supposed to do, the functional requirements, it's also the quality levels. So response time, reliability, and so on is also part of the requirement specification. Because this is an agreement, you want to involve the client in the process. You want to include them in deciding that this is a good requirement, this is a requirement that accurately captures what we want from the system. Otherwise, they'll come once you have. If you do the requirement specification without involving the client, then you'll have this very nice document, and they'll take one look at it and say, "Yeah, but that's not what I meant." Go back to the drawing board. So involve them as early as possible to make sure that you all agree along the way that this is actually what you have a common understanding of what is supposed to be built. This will decrease the risk of you delivering the wrong system, the risk of delivering the system wrong. And the customers have a chance to, along the way, refine their wishes as well. Quality attributes, I mentioned them in the slide before. So all of these service levels that, if you will, of the functional requirements. You may have heard the term non-functional requirements. So you would have functional requirements and you would have non-functional requirements. It's a bit of an immodern term, non-functional requirements, because can you really say that a system is functioning properly if it doesn't have decent response times, for example? Is it functioning properly if it crashes 5 times out of 10 when you try a particular operation? So it's more apt to call it quality attributes, or quality requirements, if you will, where you specify, if you will, a service level that I want to be able to do function X, and I want to have a response within so and so many milliseconds, and I want to be able to do function Y, and it should be it shouldn't fail on me except in these circumstances, which is more of a quality on the functionality delivered rather than a separate requirement as such. The list here is just one example of such a list, and it's not even complete. It's from a book. The point of the list in that book was to show how absurd it is to try to list all the quality requirements, all the possible available quality requirements in the world. I have a few examples that are not on this list either. And the thing is that what researchers do when they don't know what's going on is they try to categorize it, they try to classify it. So there's an ISO standard for quality requirements that structures this. Most of the quality requirements on the previous slide are here as well, but on sub-levels to these. So the ISO standard is organized according to that. You have a few top-level categories: functionality, reliability, usability, efficiency, maintainability, and portability. Under these, you have subcategories that go deeper on each of these requirements. And it's not a stopping point here either. You have to go deeper still in order to come to something which is usable. So when you look at, for example, efficiency and resource utilization, well, what does that mean? Is it system memory? Is it disk space? Is it CPU? Is it the number of CPU? Is it the speed of each individual CPU? Is it the cluster of computers, and so on? Is it the network, and so on and so forth? So you'll have to specify much deeper than this. And also, is it at peak performance? Is it when the system is working as fast as it can, or is it under normal conditions, or is it at the same time as you're doing system maintenance and doing a backup, and so on? So it's for each of these categories and subcategories, you can come up with innumerable quality requirements that detail some aspect, and you won't do all of them. You will absolutely not try to do all of these. You will find the ones that are most relevant for the system that you're building. You might use this as a checklist to just see, do we have any requirements, quality requirements under this category? If so, sure. Do we have the right ones? Yeah. If there are no quality requirements in one of the categories, is that by design? Is it okay that we don't have any quality requirements in one category or not? Is it relevant for the system? If it's a category that's not relevant for the system, then fine, we don't need to specify any requirements then. If it's a category that, yeah, actually this category is relevant, but we don't have any requirements there yet, well, then it's a sign that you need to do a bit of research and actually specifying a few requirements there. So use it as a checklist more than as a list of headings that you must fill in. Requirements attributes. Okay, so we've talked about where to get requirements, how to get them, how to specify them in terms of which the document you should have and what types of requirements that you have, both the functional and you have the quality requirements. And then we come to each individual requirement. What should be specified for one requirement? And this is one idea. A colleague of mine did a study where they tried to find all the possible attributes that you can have in requirements, and then I think they ended up with somewhere like 150 different attributes on each requirement. Obviously, no one is going to use all of them, and it turned out that of the 30 that were in use in the company that did the study, perhaps 5 were used, and a couple of more were sometimes used, but not consistently, so that some fields were used for some requirements, but not for all other similar requirements, and so on. So it was very much up to who wrote a requirement and what that person thought was relevant to specify. So defining and deciding for you in your company or your project what attributes should be available or should be present for each requirement, that's very much something that depends on the product you build again. As a minimum set, I would suggest that you have an ID on the requirement, some way that you can identify the requirement and you can link to it and refer to it from other requirements. You have a title that's descriptive enough that you don't have to look any further in most cases. It's enough to discuss the requirement. The description is the actual requirement. So that one should be there, of course. And you might actually end there, but often what is missing is an explanation for why is this requirement important in the first place. So you have a rationale, an explanation for for what this requirement is needed for. And that will help you when you prioritize requirements. It'll help you when you analyze the requirement. It'll help you when you try to figure out how to implement a requirement. If you just look at the requirement, you might not get the full story. But if you look at the rationale, you'll hopefully see a bit more about why is this requirement there, and that might help you with clues as to how to build it. Sometimes you will then see restrictions and risks on requirements. So are there known conflicts with other requirements, or are there known dependencies between this requirement and other requirements? Do I have to build this requirement before some other requirement, or vice versa? Can I build this requirement at the same time as another requirement, or are they in conflict with each other, and so on? Any risks in terms of, well, this requires us to have access to the following equipment, we need the following knowledge and expertise in order to build this requirement, and so on. This is a new technology, so we need to spend time learning that technology before we can build it, and so on and so forth. Anything that we see that might influence our ability to deliver on this requirement should be in the restrictions and risks area. And then if you have problems with the requirements, you can't understand it, even if you have the rationale there, you can't really figure out why is this needed, why should we do it like that. It's always good to have a source. Who wrote it, who said it, at what time, so that you can go back and ask for more details. And then the next bit, fit criteria in a test case. When do you know that you are finished with requirement? When do you know that you've actually built it? So putting in a fit criterion or a brief test case there is a good point, good idea, so that you can use that to verify that, well, we're done with this requirement. Now we can move on to the next one. How important is the requirement to the customer? How happy will they be if they get this requirement? How unhappy will they be if they don't get it? So, for example, if I have a feature in my mobile phone app, that'll make me really happy. That's the feature that'll make me want to pay for that mobile phone app, for example. Whereas the panic button in a nuclear power plant, I'm not really that happy that it's there, but I'll be very unhappy if it's not there. So customer satisfaction and customer dissatisfaction are not the same thing, and sometimes you will see that when you prioritize requirements, that you get priorities for both the satisfaction and the dissatisfaction. And then dependencies, are there other requirements that are related to this one, other requirements that I should look at to get with this in order to get a richer picture. So this is one set of attributes that you might consider for each requirement in your system. The actual requirements then, the description. As I said, we want that to be what the system should do, not how it should do it. So if I look at the system from the outside, if I give the system a certain stimulus, what response do I expect? Not the internals of how that response is going to be produced, just the response I get. It should be testable and it should be measurable, so that I can actually know that I'm done with it and that I've met the requirement. It should be unambiguous for the same reason that I should be able to say that now I've satisfied this requirement, and there's no different interpretation that I misunderstood. So I've misunderstood the requirement in some way. Each requirement should only be one requirement. Sometimes you'll find a couple of requirements merged into one. It should be unique so that I don't, if I look through the requirement specification, I find the same requirement in different sections, then it's not unique, obviously. So I should have, if I have a requirement, it should be in one place and one place only. That's easily said, especially if you have the one requirement specification, one product sort of development cycle. If you have a continuous product that is built over tens of years, 20 years, then it's much more difficult to figure out that this requirement is still unique, because no one remembers the requirements that you implemented 10 years ago. Then you need support with the help, for example, with the help of a database, some natural language processing in order to find similar requirements, so that you can see that this is a requirement that we've had before. So far, it's things that you can look at yourself. And then the next one, understood by all parties. How do you ensure that? How do you ensure that the customer actually understands the requirement in the same way that you do? And there's no good answer to that. You'll have to just make sure that you discuss the requirements, you develop them together, and that you, through that process, at least have most requirements understood in mostly the same way. But the brief on how to satisfy these bullets, that can be done in many different ways. You can do it with natural language text, of course, which is the most common one. You can use a figure, an image, an illustration of some sort. You can have a diagram, you can have a table, you can have a graph, and all of these are ways of implementing the same requirements. Or not implementing, specifying the same requirement. And which specification method that you should use is, again, depends on the requirement, depends on the customers, depends on your development process, and so on. So it's, you can specify a requirement in many different ways, is the bottom line. And how you specify an image together with the attributes on the previous slide, that's another story. But you can have requirements saying that according to the attributes, the previous attributes, and then you can say that this requirement shall be implemented according to image such and such. So that's one way of pointing to an image, at least in a requirement. I'll stop there for the break before I go into user stories, because it's a good breaking point. I'll pause the recording. Based on a question on the chat during the break about black box and white box systems, so with a black box system, I'm just repeating this for the sake of the recording as well. So with a black box system, we look at the system from the outside. We only see what it responds to the stimuli that I give it. With a white box system, or with a white box view of the system, I should say, we open up the box and we look inside, see how the system produces that response. Unfortunately, it's not as easy to say that well, in requirements engineering, we're only looking at the system as if it's a black box, because certain requirements require us to look inside the box as well, especially if it's legal requirements or privacy requirements or security requirements or such things. We cannot just look at the outside response for a request. We have to look at the inside of the box to impose restrictions on how it delivers something as well. But we should strive to focus on the response we get and the outside reactions we get, but it's not, as I say, it's not always possible to make that distinction. So it's but it's good at least to keep in mind that we try to look at the system as if it's a black box. Right. So this classic form of writing requirement specifications is, if you pick up a textbook on requirements engineering, this is what you'll find. You'll do the elicitation analysis validation, specification, and maintenance, and so on. Just as I've listed so far, you have requirement specific documents, and you have each requirement have all these attributes, and you have a maintenance and operation side, which is sometimes more work to do than the actual specification of the requirements, because change requests during a project it's a difficult process to manage. From the Agile community, we, as a counter movement to that, they started saying that, well, we're spending too much time documenting things and not enough time building them. All these attributes, it just takes time to figure out what to put in each attribute for each requirement, and linking them and finding out how to do that. That's just a lot of nonsense, and we might not even implement requirements in the end. So in Scrum in particular, they came up with the idea of user stories instead, which is a much simpler template. It's not. It doesn't have all the attributes. It's got a simple sentence, like, as a certain type of user, I want some goal so that I can fulfill some reason. If you look in the course, I think I have user stories in the different modules, so you can get a few examples there. As a student in software engineering, I want to know how to do requirements engineering so that I can understand what the customers are telling me. Normally, you would write these user stories on post-it notes or index cards, yay big, so that you can put them on a whiteboard and you can move them around, you can prioritize them, you can talk about them, you can group them, and you can take a whole bunch of them and put them aside for now, and so on. So it's quite common that you see this written on post-it notes, or the size of post-it notes at least. Often you'll see that on the back side of it, you'll have an acceptance test defining that when am I satisfied as a certain type of user that this goal has been fulfilled. And this is a much simpler way of working with requirements. It also has the ability to have a vagueness built into the requirement if I want to. So the idea is that the requirements that I'm going to work with right now in the coming 3 weeks, they need to be crystal clear. I need to have a user story which is well enough specified on a level of detail, sufficient level of detail, so that I know how to build it. And I've got acceptance test on the backside. But for a requirement that is a year into the future, I don't need that level of detail. I don't need that clarity. So with a requirement that's that far ahead in the future, I can deal with something which is much more blurry at edges. We might, in a year's time, consider going into the Chinese market. That's a giant requirement, and there's very many things that goes into we're entering the Chinese market, but it's not relevant for us right now to specify everything that entails, because we're not there yet. Whereas I need the login button moved 3 pixels to the right, because it's interfering with the username box. That's something that is very concrete and very actionable right now. And then as time progresses, and this epic, as they call them, these big requirements that are, or big in the sense that there's a lot of things to implement in them. As time progresses and this epic becomes more and more important, it's suddenly the most important thing that we do that. We don't have anything more pressing to do. Then we'll break that down. We'll open up this, we're entering the Chinese market, and see, what does that mean? Well, we need support for pictograms in our text. We need a different keyboard on our application. We need different images, whatever, and so on. and then we can have a detailed discussion on what is the most important of those, and then break them down into further details again, so that the requirements or the user stories that I'm going to work with for the coming 3 weeks, they are clear enough so that I know exactly how to build them, but not clearer. There's no point in specifying too many details either. It should be sufficient so that I understand how to build it. It should be sufficient so that I can talk to the customers about them. And that's why I have the type of user there, because the type of user will tell me if I need more information, whom to go and ask. And again, I've got the acceptance test on the backside, so I know when I'm done with it. Now I know when I can move it from the working on pile to the done pile. But the idea is that rather than having this lengthy requirement specification that we agree upon and sign a contract on, it's the contract basically says that there's a backlog of requirements and we'll add things and remove things as we go along, and you'll be paying us for the development until you're satisfied. It's a different way of charging for a project, and it's a different way of thinking about requirements. That changes very much the focus. So from the old classic 2 years hidden in a bunker type of development projects, where change requests are really important. Who gets to do a change request? How do you deal with the change request? And how do you reprioritize your entire mass of requirements based on this changed requirement? And how does it enter the development process and so on? With an agile development methodology, everything that's in the backlog that we haven't implemented yet is free to change and add and reprioritize as you see fit, but then we'll take the top of that, the most important things, and for the coming 3 weeks, that's what we're building. If you have something that you'd like to change on those within those 3 weeks, well, no, but we'll happily change for the coming 3 weeks. So you re-emphasize the importance of the development activities that you do when you work with an agile requirements engineering process. So a colleague of mine, or two colleagues actually, they looked at, they were working together with a company, and they got, as I mentioned before, many requirements, tens of thousands of requirements, and they needed a strategy for dealing with that. And what they realized was that all requirements are not shaped in the same way. That would be fun. That would be nice if all requirements are specified in the same way. But what they did was that they discovered that you have requirements that are more like goals, like we're entering the Chinese markets. You have feature requests that I want the system to do function X, whatever that might be. And then you have functional requirements that are more details. When doing function X, I want it to do it in this and that way. And then you have component level, which is even more broken down. That might be the inside of the system, specifying that, well, it should also adhere to this and that standard when it stores data on the disk or whatever. And just the fact that you recognize that you have these different levels. So when you get a new requirement, if you look into your support database and there's a requirement waiting for you to deal with there, what level is it on? Is it a goal level requirement? Well, in that case, it's not something that you should decide on here and now. That's something that you put into the product manager or the product management board, that we've got a new goal. Is this something that we should pursue in the future? If it's a feature requirement, well, can you link it to one of the goals that you already have? If you can, good. Then it's something that you should do. If you can't link it to one of the goals that you have, do you need to create a new goal? Again, it's up to the product management. And then same thing with function requirements. If it's on lower levels, if you can find a feature that is related to that function, if it's a feature that you're supporting, then you can decide whether to do it or not. If it's not in a feature that's available at the moment, then probably you shouldn't. But again, you leave that to someone else to figure out, is this a feature that we should have? And in that case, what goal are we working, does this feature support? So that was one way of getting help in deciding which requirements to focus on or not. And it's not about when you invent requirements. This is about when you get requirements from your customers or wherever you get them. But on the other hand, it's equally applicable if you invent requirements yourself. But it's a way of triaging the requirements, figuring out what should you be doing, what should you absolutely not be doing, so that you can filter among the requirements quickly, and come to a conclusion about well, what to do next, really. So let's take an example. This is a requirement you see far too often. The system should be easy to use. What's wrong with this requirement? Well, first of all, there's an RFC standard for whether we should use should or shall or must or may, and this RFC says that should is, well, it's an optional thing. So what we're saying is that the system may be easy to use, not must be easy to use. So if we wanted to have it binding, then it should be shall. The system shall be easy to use, but that's a minor detail. The problem is that we still don't know, what does it mean to be easy to use? For whom? And what kind of system is it? If I'm building the control software for a particle accelerator, then easy to use is a very different story than if I'm building the software for a doorbell. So I need to have more details in order to say if it's a good or bad requirement here. So let's specify it properly. First of all, we've got an ID. We have a title, usability for new users. Okay, so now we know for whom. It's users who aren't that familiar with the system. And the system shall be easy to learn for new users. Is that actually really better? We're still saying easy to learn, and what does that mean? Why is this important? Well, the average user isn't very computer savvy, so we need to help them in this. Who said it? Well, we have a source. And then we have, because this is a quality attribute, we've got a value scale. So we specify how should we measure our success in this? Well, we have operations that you can do on the system, and we measure the number of hours it takes to learn how to do them. And we want each operation to be doable within half an hour. But we'll be okay with 1.5 hours. So we've got some sort of measures there at least. So easy to learn is if we're within the 1.5 hours for each new operation. I mean, this is probably a very difficult operation then, because 1.5 hours to do a new operation is probably not the easiest system. But at least there's a measure there. The next one, the user should be able to log in. If the user fails to log in after 3 attempts, the user account should be locked. Again, with the should and shall, that's one thing. The other thing is these are at least 3 requirements. So that what we're really asking for is that this user should authenticate themselves. That's one thing. And then there's another requirement. How many attempts do I have to authenticate myself before something bad should happen? And then there's the consequence of failing to authenticate myself. So those are the three requirements here. Log in sort of implies that it's username and password, right? So authentication gives us more leeway to do other things like fingerprint, PIN codes, and so on. Facial recognition. So authentication is perhaps more important than logging in. Um, and login and authentication is one of those things that if you sit down with a pen and paper, you can probably easily write up 300 requirements on just about the login process. How many attempts they have, how much time should go between each login attempt, what is a good password, what isn't a good password, what's a good username, and so on and so forth. And other areas of the system where we're not as familiar, support for pictograms. We probably can't write 300 requirements on, but then when we do prioritization, the classic prioritization methods will take each requirement and compare them in some way or other against all other requirements. So support for pictograms is now competing single-handedly against your 300 login requirements. And of course, login is going to be more important then because it's got 300 more chances of becoming important. So that's a balance that we need to be aware of when we write requirements and when we prioritize with our requirements, that we don't over-specify the things that are simple and easy to us just because we can. That comes back to the user stories again, that enough details so that I can start implementing it, but not more. So as a manager of the system, I want all users to authenticate themselves so that I know that they have the right to be there. That's sufficient for you as a software engineer to figure out, well, I need some form of login. You don't need all these details about failed login attempts and so on. You know those things, so you'll implement them anyway. Okay, backing off a bit from the specification and the requirements themselves. So customer contacts, it's basically it's a professional meeting between you as a supplier and someone who is willing to give you money if you behave. So of course that should govern how you deal with these things. You're respectful, you show that you're responsible, that you know your stuff. You will you commit to something against the customer. You are, when they say something, you make a note of it, and when you promise to deliver something, you actually will deliver on it. Come across as a professional, come across as believable, that you are actually a software engineer that know what you're doing. There's a discussion whether you should deliver at least what you've agreed upon, or at most what you've agreed upon, or both. I'd say that there's a balance there, that of course you shouldn't deliver less than what you've agreed upon, otherwise you'll have a dissatisfied customer. But you shouldn't deliver too much more either, because that means that you could have gotten paid for that at least. Sometimes you will deliver more because it'll get you the repeat contract. Doing a really, really good job, even if that's not what they asked for, will mean that, yeah, next time they need a software engineer, they might come back to you because, well, you did good last time. So this is always a balance. Is it just one customer, one stakeholder that you should be in contact with? The person sitting on the money isn't always the most knowledgeable about the system that you're going to build. And how do you get access to the persons that do know the system that you're building without offending the person with the money? This is very much not a technical skill and very much a people skill. And you have to treat it as such. So when you have customer meetings, you're prepared, you're the ones that are in charge of the meeting. You're the ones that have to show that you're professionals. The customers know that they are professional because they have money to give you. So you have to show that you're worthy of receiving that money. So you're prepared, you have an agenda, you have done your homework as much as you can beforehand. So you have an idea of what type of system that they want. I mean, they will have at least contacted you and said, well, we have this idea of a system that to help us with our such and such process, and we would like a meeting with you to discuss this further. So such and such process. You'll do your homework on that. You'll read up whatever Google has to say, or any other search engine for that matter. What you can find for information about that such and such process, so that when you come to the meeting, you're able to ask informed questions that shows that you understand at least the starting point of what the customer wants. You don't come unprepared and say, yeah, right, we've got a pen. That's a good starting point anyway. And now tell us everything that you want from the system. You show that you are interested in getting this system and delivering the system to this customer. Make sure that you document what is said. Ask for permission to record it if you are unsure if you're able to write down things as they are said. Quickly or as soon as possible after the meeting, come back to the customer. Thank you for the meeting yesterday. It was really interesting, and here's a summary of what we learned in this meeting. For example, as a draft requirement specification, or some form of summary that this is what was said during the meeting, so that the customer can come back to you and say that, no, you've misunderstood here, or I think this is really important, you should focus much more on this, or you missed this complete discussion over here that we had. So that's important that you come back to the customer as soon as possible after the meeting and with a summary. You are in control, you should act it as well, so be professional. Sometimes looking at movies and how adult behaves in these situations and pretend to be an adult actually helps. Before you know it, you're an adult yourself, really. Contracts. What should I say about contracts? It's a legal document, of course. It's an agreement between you and the customer. Now, verbal agreements are valid, so if you say something and the customer will decides to hold you against it, then they have a right to do so, but it's difficult to prove, so you want it in writing. What you should deliver, what the customer should deliver, what your responsibilities are, what are the responsibilities of the customer, and so on. So we'll put all of this into writing, and that means that you have something there to lean back upon. Now, a contract is something that you write them because you have to, and you hope that you never need to use them. Because if you need to use them, you are in some form of conflict with the customer. They don't think that you've delivered what you should, or you think that they have done something or asked something of you which is not part of the service that you've promised to deliver. So if you end up using the contract, then something has gone really wrong. But you still want to have that. You still want to have that security that there is a contract signed about how to deliver and what to deliver and when to deliver and so on. Different contract types, different ways of setting up a development project. You can do fixed price. Basically, it'll take as long as it takes, and you pay us a certain specified amount of money for doing this project. You run the risk there if it takes longer, or if there are changes, then and if that's not part of the contract, then you run a risk of working for free, really. Running price, basically working on the meter. Means that you get paid for everything you do, but the customer, on the other hand, is sitting on all the risk that you will be working slower than expected, or there are problems that you hadn't anticipated beforehand. So you push the risk to the customer instead there with the running price. Cost plus is sort of a compromise that it'll cost this much to deliver the basics, and then we will work on an hourly salary after that to deliver what else is required. But we could also combine this with a roof pricing, that it'll never cost you more than this. So you can pick and choose, and you can combine these different types of contracts, but you should be aware that there are different ways of charging for your services, really. And explaining this to this group is perhaps less important than to the Swedish students who are not quite as from quite as an entrepreneurial society as you are. So you probably knew all that already. Items to have in the contract. What services will you be delivering, during what time, what deliveries will be delivered at what time, whom to contact on both sides, what it'll cost, what actually will be delivered, and so on and so forth, and then relate that to requirement specifications, maybe even a project plan, so that you have an idea of that. I'm not sure about that, because that means that you can't even replan your project without renegotiating the contract, but sometimes you'll see that. Important to note, the contract is an agreement. This is what we promise to do. This is our commitment. As long as we get the following from you as a customer. So if you're supposed to work on some sort of data or have some sort of legacy system to work on and build upon, then of course the customer has to deliver that to you in order for you to do your job. And that should be in the contract as well, that we promise to deliver this functionality, but we also need access to the following systems in order to be able to deliver that. And if you're unsure whether you can deliver what is specified and so on, don't sign. That's the basic. You only sign the things that you actually know that you're going to be able to deliver. Right, that was a long excursion out of the UML world. So let's get back to use cases and unified process. We can, of course, express requirements as use cases as well. A use case is probably, or depends on how you see it and where you come from, but you can combine several requirements into one use case, and that's okay. The use case is one scenario of how to use the system to address or to achieve a certain goal. So they are closer to user stories. They're not at all the same thing, because you have more details in a use case, and it's more implementation-y. But the idea that the goal of a use case is to accomplish a certain goal against the system, or the intention with use case is that, and that's sort of similar to a user story. So if we look at this requirement, but first of all, is that a good or a bad requirement? Users shall be able to view a personal calendar and recent notifications in the system. If this is all we've got to go for or go with, then it's not a good requirement, because you have this "and" here. It's sort of a telltale that you actually have two requirements. I shall be able to view a personal calendar is one requirement. I shall be able to view recent notifications in the system is probably a different requirement. But we can still express it as a use case, even if it's not the best of requirements. We can say that we have a use case, view calendar and notifications. Who is involved in it? We've got our system users, and we have a description of what's going on. So user requests to view their personal calendar, and system displays the user's personal calendar, and we request to view recent notifications, and the system displays the recent notifications. So if we are going to build a system using UML and the rational unified process. We are probably going to work with use cases sooner or later. And in that case, do we really need to specify requirements as requirements according to the RFC standard and IEEE standard? Or can we get away with specifying the requirements in the form of use cases? I'd say that we probably can. There's no point in writing first requirements and then rewriting them as use cases immediately after. There are some benefits of having requirements as well, because not all requirements are expressible as individual use cases, especially quality requirements or links to certain business processes and so on. But I would rather deal with them in a nice way than having to repeat myself first as requirements and then as use cases. So that much about use cases. I said it was a brief return to the UML world. Now, requirements and requirements prioritization is a big research topic in and of itself. There are many different methods. Let's see, I've got that here. We can prioritize requirements by just assigning a numerical weight to them, saying that, well, from a scale from 1 to 10, how important is this requirement? And then you rank that, it's an 8. And then the next requirement from a scale from 1 to 10, how important is this requirement? Well, it's a 7, and so on. That's one way of prioritizing requirements or use cases, or whatever you're prioritizing. You can narrow this down, because then you start, if you have numbers like that from 1 to 10, well, what does it mean that you gave that one a 5 and this one a 10? Is the 10 twice as important? And what's the difference between a 5 and a 7? Well, it's 2 points, but what do these 2 points mean? And so on. So in order to avoid that, you can use a discrete scale, saying high, medium, and low instead. Problem with that, it's the same as for scored requirements, is that 80% roughly about of the requirements are going to end up in the high category. They are of high importance. Of course they're important, otherwise I wouldn't have mentioned them, right? And then you have the remaining 20% over medium and a few of them in the low category. So you end up prioritizing the requirements, and in the end you don't have any priorities either, because they're all equally important. They're of high importance. So a way of coming around that problem is that you do ordering of some sort. You can use simple ordering like bubble sort. We don't really care about how many points you've got. You've just got an ordered list saying that the top one is the most important one. And I don't care how much more important it is than the second one, because it's still the most important one. It's the one I should focus on first. Cumulative voting is similar in the sense that I get an ordered list. I get a few other benefits that they are on a ratio scale and so on, but at least it's an ordered list. So cumulative voting is that I say, here's 100 points, and here's the set of requirements. Now distribute those 100 points on the requirement so that the most important requirement has the most points. But you only have your 100 points. It's also called the $100 method because, well, 100 points, $100. In the end, what you have is an ordered list there as well, and you have a ratio scale so that you can say that one requirement is twice as important than another requirement. For why you would need that, I don't know, but you can at least do that. Moscow is a method that you'll see often in agile communities. It's sort of like a discrete ordering, but we avoid the medium and low categories at least. We say that some requirements are must-have. For this release, we must have these requirements. And for these requirements, well, we should have them, but it's not absolutely critical that we do. And some other requirements we could have, well, if we've got time to spare, we can put them in as well. And we have the final category, won't have that. Yeah, that's not relevant right now, so we won't have them. So it's by it is a discrete scale in that sense. It's just 4 categories, but the naming of those categories and how you use them makes it slightly more useful than just high, medium, and low priorities. So these are some of the commonly used requirements prioritization techniques. And then if we go back to what Craig Larman has to say about use case ranking, they say that if a use case has a direct impact on the architectural design, then it's more important. That means that if you have a use case that will help you build more of the system, the underlying structures of the system, the scaffolding, if you will, well, it's more important that you get to that requirement sooner rather than later. This will help you build what's called a minimum viable product. The smallest possible product that still exercise as much of the basic structures of the project of the system as possible. So if you're adding classes, if you're adding components, if you're adding a database, if you're adding new computing nodes and so on, well, that's an impact on the architectural design, and those are things that we should focus on early, so that we get the basic structures, the underlying architecture, the scaffolding in place as quickly as possible, and then we can start attaching more functionality to this, and the rest of the system will be easy to build. If there are risky or time-critical or complex functions, well, do them sooner rather than later. The more time you've got to realize that this won't work, the more time you've got to rethink your strategy and try a different solution. So if there is something that you're unsure of, well, start with that. That's actually a good advice in life as well, rather than pushing the unknowns to the future until last possible minute, and then you realize that I don't have time to do it because I couldn't do it in the way I thought I could. If you do that as soon as possible, you have more time to raise the alarm, rethink, find different approaches. So if a use case sounds like, well, we don't really know how to build this, well, do it as soon as possible, so that you have a time to learn, you have the time to show to the customers and discuss it even further. Same thing with new research or technology, because they are by definition unknown and uncertainties. You want to try those out as quickly as possible. If a use case is a primary business process, if it's something that the customer can start using immediately and is of value to them, then the sooner they get it, the sooner they can start using the system, the happier they will be. The happier they will be to continue pay you to develop the rest of the system. If you develop the system, let's take the other extreme, you develop the system exactly the other way around, well, you deliver something every week, but they can't use it because this primary business process isn't there. And they keep paying you and they keep paying you, and a year from now finally here's that feature that you've been waiting for, and now you can start using the system. Of course, they are going to be more reluctant. They are going to, even if you've been delivering all the time, they're going to think that, well, you're really slow developers. We really needed this feature a year ago. So deliver those things as soon as possible. And in the same way, if it's something that can support revenue for the customers or for you, or decrease cost for you and for the customers, if you can do that as soon as possible, again, we only got the first release, and you're delivering new releases every week, but already with this first release, we are saving money. And that means that they will see it as they're not paying you to build a system. They are saving money by allowing you to build a system. And then they are much more inclined to continue paying you. So these are rules of thumb for how to prioritize your use cases or your requirements. And of course, you can have one use case with which ticks all of these boxes, or it might tick none of these boxes, and your end priority will be accordingly. That you go through the list of use cases, and yeah, this one is really important. It's got an impact on the architectural design, so I'll move it up a notch. This one down here, it's time critical, so or risky. Well, let's move that up to almost the same level. So it's not something that you just push them one step up or down. It's something that, well, these have some of these characteristics. They have impact on the architectural design. These are time critical and so on. So let's do them in some order, and then you order them against each other as well. So it's not so much a method as such, it's just rules of thumb for what would make a use case or requirement more important to implement. And that actually, I think, was the last slide for today, which is a bit of a surprise. I normally have like between 5 and 10 slides left in this lecture when I'm done with the time, but apparently today I managed to finish it all. So I'm stopping the recording now.